In this problem, it tells us that square SQUA has a side length of 5 units. Now, the main difficulty with this problem is the way you draw it. So let's draw out the first square. SQUA. All right. The next one, square AQBZ, is drawn such that point B is closer to point U than to point S. Now notice it's got 2 points mentioned already, A and Q. So here's one side of this square. And then it says that point B is closer to U than to S. So that means we're going to draw it this way, not this way. And so the other 2 points are B and Z. And then the third square is ABCD. So we're going to connect A to B, like that. And then it says that point A is between point S and point D. So that means point D has got to be down here somewhere. So when we draw that down here, that means point C has to be over here, like that. All right, so we want to determine the exact length of SC from here all the way over to there. Now they gave us that in this square, the side lengths are 5. Now for this next square, this side is the hypotenuse of this right triangle, and it's a 45, 45, 90. So that means this is 5 radical 2 are the lengths of these sides of this square. And the same thing is true for the third square. This side, A to B, is the hypotenuse of this third side. So that means we're just going to multiply this by radical 2. Now 5 radical 2 times radical 2 is going to be 10. All right. So now what we have is we have a right triangle formed here and formed here. So we got 15, we've got 10, and we've got SC. So 15 squared plus 10 squared equals SC squared. So we square 15, we get 225. We square 10, we get 100. So we have 325 equals SC squared. But to get SC by itself, we have to take the square root. And so we have to write the answer exactly. And when we write a radical, it needs to be in simplest form. So it's not an even number, so we can't divide it by 4. But let's see if we can divide it by 25. Yep, we can. We can break that into 25 times 13. And so that's 5 square root of 13 equals SC. And there's our answer. And we're done.